Okay, today we're going to be looking at stretches. So we're going to consider the function y equals x squared minus 2x minus 3, and I've drawn it on this curve. And we're going to compare it to the same curve, but we're going to multiply it through by 2. So let's draw this on here. Now it's going to go through the x-axis at the same point. I'm not very good at drawing. Oops. Oh, I might have done that wrong. It should be round. It's up here, and it's going to go down. There. Now, what we have here is if we were to look at a point on the black curve, and same point, same value for x on each curve, you would see it was stretched by a factor of 2. So the x coordinates are the same, but here, I'll look at the blue again. A big long shade of blue, but never mind. Y equals 2, and the black y. So we see that this means that the blue curve is twice the distance from the black curve at each given point of x. Now what we can do is we can say this, we can explain this stretch in different ways, but each way that we explain it, it means the same thing. So a stretch with scale factor, so when we see that's each point here is 2 times 2 away from this one, we call this the scale factor. A stretch of a scale factor 2 with the line y equals 0 invariant. Or we can say a stretch, we can describe this as a stretch with scale factor 2 with the x-axis invariant. Or a stretch with stretch factor 2 relative to the x-axis, or a vertical stretch with scale factor 2. They all mean the same thing. And in general, the graph of y equals a of f of x is a stretch of y equals f of x with scale factor a parallel to the y-axis. So that's a general rule. Now A here, A can be less than 0. Then can be considered to be a stretch of f of x with a negative scale factor. Would have a negative scale factor, or a stretch with a positive scale factor followed by a reflection in the x-axis. Let's consider another situation. Let's consider this is going to be the same curve. So again, we've got y equals x squared minus 2x minus 3, which we will put on our, try and make that a bit straighter, marginally straighter on our grid here. And we will do another one. So we're going to do this time, we're going to do y equal, now we'll put 2x squared minus 2x minus 3. So what we've done is we've taken the x and we have changed it, the x, and we've changed the x and made it 2x in the function. So what will this look like? This is going to look like, let me just make sure I do this correctly. Okay. So what we've got here is if we have a point on the y, it's going to be parallel to the x-axis this time, and for the y is the same. It's moved along by a half. That's meant to be multiplied by a half. So the two curves are at the same height. The black one. The two curves are at the same height. So y equals y. When x equals 2x, or x equals half x, and that's where we get that half there. Make it show up a bit better. There we go. This means that the two heights of the heights of the two graphs are the same when the blue curve has half the horizontal displacement from the y-axis as the red curve. Therefore, y equals 2x squared minus 2x minus 3 is a stretch of the graph of this function y equals x squared minus 2x minus 3 from the y axis. So the previous one that we did, the stretch was, if you can imagine a rubber band on the x-axis, it was pulling it up and down on the x-axis. This, if you imagine it being tethered with the rubber band on the y-axis, is going back and forth on the y-axis. So on this example, we're parallel to the x-axis, where on the previous example it was parallel to the y-axis. We say it has been stretched with a stretch factor of 1/2 parallel to the x-axis. Now, the general rule is for y equals f of a of x, it is a graph, it is a stretch of the graph y equals f of x with a stretch factor of 1/a parallel to the x-axis. So this is something you need to remember. So let's look at a couple of worked examples. So let's look at this one firstly. The graph y equals 5 minus 1/2 x squared is stretched with stretch factor 4 parallel to the y-axis. Find the equation of the graph. So let's let f of x equal 5 minus 1/2 x squared. Now the stretch is parallel to the y-axis, so it's going to be that up and down stretch. So we're going to have 4 f of x. So it's going to be 4 times 5 minus 1/2 x squared, which will be 20 minus 2x squared. So this will be the resulting graph. Now let's do another one. Describe the transformation that that maps y equals x squared minus 3x minus 5 to the graph y equals 4x squared minus 6x minus 5. So let f of x be x squared minus 3x minus 5. Now let's look at the two graphs. Well, we can see that if we replace x by 2x, we're going to get this. So let's make 4x squared minus 6x minus 5, and let's equate it to, let's make it look more like this. So we'd have 2x squared minus 3 2x minus 5. So you can see if you square this, you're going to get the 4 here, 4x squared. 3 times 2 is going to be 6, so you get the minus 6x, and the minus 5 is going to remain the same. So this must be f of 2x. Therefore, the transformation is a stretch parallel to the x-axis with a stretch factor of a half. So I hope that helps.